So this is a pretty challenging problem if you haven't seen something like it before. So let's step through it together. So we have a function, a cubic function, and there are 2 points on that where if you draw a tangent line, like so, it passes through the origin. So we have two tangent lines on our graph such that their y-intercept is 0. We need to find the points where those are tangent to. So just to simplify the problem a little bit, we have our xy grid. Let's just have a parabola. It's a simpler shape, and there'll be a point on that where when you draw the tangent line, it goes through the origin. So how do we approach this? So tangent lines, remember, have the same gradient as our original function does. So our first step should be to find the gradient function, right? Take the derivative of f of x, which gives 3x squared, right? The 3 comes out the front and we subtract 1 off the power, minus 6x minus 4. So that's our gradient function, f prime of x. Now, in a problem like this, it's good to introduce a constant, for example, a, instead of x, because x represents any possible number, but we're looking for a specific number. And what I mean by that is, let's suppose that the x value is a. Again, it's just a number, it's a constant. The y value would be f of a, right? When we substitute in that value into f of x, we will get the y value. And we can work out the gradient using f prime of a. However, the gradient of the tangent is also rise over run, where the rise is 0 to fa, and the run is 0 to a. So that gradient is rise over run. And it will be equal to our gradient function where the input is a. Alright, that is the hardest step to recognize in my opinion. So let's go through that once more. But feel free to take it from here if it's clicked for you. So again, we have our curve. In this case, I'm using a parabola just to simplify it a bit. There's a point where we draw this orange tangent line such that it goes through the origin. So the gradient of that tangent line is given in 2 ways. So one way is its rise over run, and since it starts at 0, 0, the rise is just up to the point, in this case f of a, right, the y value, divided by the run, which is the x value, in this case a. So that gives us the gradient, f of a over a. But that gradient is also equal to the gradient of the function at that same point. Right, that's the definition of a tangent line. It has the same gradient as the function at the point that it intersects. And that gradient is given by the gradient function f prime, right, where the input is the x value. In this case, that x value is a. And that's all we need to answer this problem. Right, with that, we will substitute in, so f of a is, again, it is our function, but instead of input x, which is the variable, we input a constant a. We just happen to not know what the constant is yet. So that becomes a cubed minus 3a squared minus 4a. and again that's the rise, all divided by the run, which is A, is equal to, let's just move this over a little bit, is equal to the gradient function with input A. So we worked out the gradient function. Now let's input A in for x. So 6a minus 4. Alright, and looking at the left hand side, we can simplify, and that becomes a squared minus 3a minus 4. We can take everything to one side of the equation to get a quadratic equation. So I'll take everything to the right. So what's that? 2a squared minus 3a plus 0 is equal to 0. And so solving, we'll factorize a, so 2a minus 3. So for this product to equal 0, either a equals 0 or 2a minus 3 equals 0. So a equals 3 over 2. Alright, so we found our values for a, and a reminder, a is just the x value of points A and B. And we know we chose that because we restricted the gradient at that point to equal the gradient of the tangent line that goes through the origin. Right, so this green f of a on A only works because it goes through the origin. Cool. So what next? We have found the x values of points A and B. We were asked for the coordinates, so our last step is to find the y value using f of x. So finding the y values. So when x is 0, it is x cubed minus 3x squared. So x is 0 cubed minus 3 0 squared, what was it, minus 4x, so 4 times 0, which 0 minus 0 minus 0 gives 0. And then when x is 3 over 2, 3 over 2 cubed minus 3 times 3 over 2 squared minus 4 times 3 over 2. If you put that in on your calculator, we get negative 9.375. So therefore, points A and B are 0, 0, and 3 over 2, negative 9.375. Awesome. So, just going back to the question, have we finished? No. What are we missing? We need to give the equation of each tangent. Alright. So, how do we do that? Well, we know the intersection points. So let's use that. We know equation of a tangent is mx plus c. However, for us, the y-intercept is 0. Right, so it's just the gradient. And wait, how is that going to work with point A being 0, 0? Please hold. Yes. Yeah, got it. Genius. Here we go. So all as we need is the gradient of the tangent, right? And we know the gradient function up here. And we worked out the x values of points A and B, so we can substitute them in for x to find the gradient. So doing that, so it's 3x squared minus 6x minus 4. So f prime of x equals so when x is 0, the gradient is -4, which gives us the tangent line of y equals -4x. All right, no y-intercept because we know it passes through the origin. Similarly, when x equals 3/2, we find the gradient of that tangent by using the gradient function when x equals 3/2. And that gives us -6.25, which means the equation of the tangent is y equals minus 6.25x. Alright, so let's recap this question. So starting off with a function, a cubic, where two tangents to that cubic pass through the origin. So dealing with a tangent, our first step was to find the derivative. Yeah, and actually if you did that and you made some progress to the solution, you would get achieved. We then did a little sketch to acknowledge that the gradient of the tangent, the green, rise over run, must equal the gradient of the function at the same x value. Right, so we introduced a just to avoid confusion. And then substituting that into the function and into the gradient function, we got this mammoth equation here. Thankfully, some of the a's cancelled and it's simplified to a quadratic equation. Yeah, and that's good news for us because we can solve that. We factorized and solved for a, which tells us that on the cubic, when x equals 0 or 3/2, the tangent lines at that point would also pass through the origin. And then finally, we had to find the y values by using the original function. So when x is 0, y is 0. When x is 3/2, y is -9.375. And sorry, finally, we then found the equations of the tangents, which were actually quite straightforward because we only needed the gradient using the gradient function. Yeah, because the y-intercepts were 0. And getting that far would be excellence. If you only found one equation and 1 point, that would be merit. Cool. Alright, and I mean, if you want to leave, bye, but I'll just show you on our calculator to verify this solution. So here is our graph, the cubic, and now when x equals 0, if I go shift or sketch tangent, T-A-N-G, and I want x equals 0, so 0, sketch a tangent. Right, the equation of the tangent is -4x. Yeah, so that can just verify our solution. Alright, I think it's time to play some games for me. You make sure you have a study break too, and see you next time.